Hello everyone. I wanted to do a video for you for the Project 1, Rescuing the Countess, and I'm going to be doing this for each of the projects, as I did for Project 0, except obviously this one I'm not going to just hand you the code, but I want to talk about the important issues. So I've got an outline here that's going to be the first important thing for you. How do you get started on this project? So the first two, read the specification, read the Project 1 STL and U document. Those are both on Canvas. Be willing to come back to either one of these documents as needed. Now then, when you start writing the code in Project 1 here, there are no starter files, so you've got to start writing the code, and we're going to talk about chord organization in a little bit after we get through our what to do, then we'll get to how to do it. So when you start out, you can read the command line, process the command line options, and this is going to be something that you do for almost every project, and a lot of it is going to be copying existing code and modifying it. So if you've done Project 0, great, you've already got a lot of the learning done for this part of the project. Next one, reading the input. And when I say pick a format there, I mean like either map mode input or list mode input. Let's get one of those done. Excuse me. Next, we want to work on having a deck and performing the search. That's the part of the project spec. I should have had that ready. That's the part of the project spec referred to as routing schemes, which is on like the middle of page 4 is where it starts. So you go through the routing schemes to process the data and do the searching. And let's just, at least at a first attempt, you could just worry about does a solution exist or not. And there's going to be more data and more record keeping needed to know what that solution is. So you could do this step and this step together first, or you can do them one at a time. But these are things you have to accomplish, so we can reorder things a little bit. But we've got to be able to search using a deck, and the Project 1 STL and U will explain to you why we want to use a deck. And the output, if there's no solution, is really easy. So if you can get to the point where you know a solution does or does not exist, the output when there's no solution is easy. It's basically just making sure that you count up how many tiles you discover and output that. It's basically declare a variable and set it equal to 0, increment a variable, and a cout statement. So that's pretty easy. Then having your search be able to keep track of the information that you need to backtrace to go and know what the path is a little bit harder. And we use the word backtracing here on purpose because when we get to later in the semester, like the last project, we're going to talk about backtracking, and backtracking has a specific terminology and what it means. And we're not doing that here, so we don't want to have terminology confusion later. So when we talk about finding your way through this discovery of how you got from the start to the Countess, we're going to call that backtracing. Okay, so then we want to be able to do that. We got to keep track of the information to make it happen, and we'll talk about that in a few minutes. And then you've got to have the output when a solution does exist. Again, pick a format, map mode or list mode. Now on this pick a format, let's just go back to reading input. I think the map mode input is a little bit easier to code up. When you do the output, it may not look like it, but list mode output I think is easier to code. I wrote a new solution to this project from scratch, and I found it that way also, and I know the project well, and I still thought the list format was easier to do for output. So input I found map format easier, output I found list format easier. Okay, then once you've got all this code written, you've got to obviously get it working. And so for all of the samples that we give you, you want to get the right output if possible. And once you've got that, then you can go back and get the other output and input types. And which order you do those in isn't critical, but once you know that the searching is working, or at least close to working, then you can worry about the other input types. And this is also one thing to remember about our projects in 281 is they are made to be built in pieces. You don't have to know how to figure out that list mode input to start the project. You can do it later. So always be willing to make your plan, do some planning, do some designing, and get in there and start coding, even though you don't know everything you need to do to get the project done. This also gives you the opportunity, if it's 10 o'clock and your searching isn't quite producing the right output all the time, but sometimes it is. There's no more office hours today, and you've still got time you want to code, but you can't figure out how to fix the searching. You need to ask some questions. Well, then go down to this step. Go do another input mode. Go do another output mode. And then when you've got time the next day to get some help in office hours, then you can make some progress on your searching. Okay, other things we want to talk about. Let's see. All right, so when you start organizing this code, I would suggest having a class. And there's going to be more to it than this, but I would suggest having a class. Let's talk about a spectrum of good to bad, all right? Or bad to good. Bad to good. Let's start with bad. Bad would be like 1,000-line main with duplicated code and no functions. And can that work? Yes. Is it easy to read? No. Is it easy to debug? No. Is it easy to optimize? No. And so that can work, but when things go wrong, it makes it harder, okay? Second best would be, okay, I don't have a 800 or 1,000-line main, but I've got a bunch of variables in main, and I've got several functions outside of main that the data that's declared in main gets passed to this function, and then it gets passed to that function, then it gets passed to that function. That would work also. Better still would be to have a pretty short main that declares an object of a class, tells that object to do things like, hey, object of my class, go process the command line, go get the options, go read the input, do the searching, produce the output. So main is pretty short. It consists of sync with standard IO false, don't forget that, declare an object, call a couple member functions on that object, return 0. And then the rest of the code goes into that class and into the member functions of that class. So what would be the member variables of that class? Well, one group of things that would be good member variables of that class would be everything that you have to get off of the command line. What do we have to get off of the command line? We've got, is it stack or queue? Now, once we're done processing the command line, we don't need, and you don't want to use a string for what type of container you're supposed to be. String comparisons are slow. Later on, when you have to say, is it a stack or a queue? You don't want to compare a string, because if it is a stack, you have to compare. Is S equal to S? Yes. T equal to T? Yes. A equal to A? Yes. C equal to C? Yes. K equal to K? Yes. And at the end of both of them, yes, then I must be done. That's a lot of work. But if, as I process the command line, I remember everything that happened as maybe local variables, but the Boolean the member variable could just be a Boolean. Is stack mode on or not? Or is queue mode on or not? Because then later on, you're just going to do an if. If stack mode is on, do it this way, else do it the other way. So when we're processing the command line, you've got to do more. You've got to know, was there a stack or a queue on the command line at all? Was there more than one of them? That's in the errors you must check for section. But once that process the command line function is done, all I really care about is, was it stack or was it not stack? Okay, so that's one thing that's got to be remembered. What is the output format? And that you could remember as a string, because we're not going to check it often. The if it's a stack or a queue could potentially be checked millions of times. But the output format requested on the command line, you could save that as a string. You're only going to check it once when it's time to do output. So who cares if it's fast or slow when you do it once? Okay, so then other things that you would have as member variables would be, hey, if I'm going to have a function that reads from the input, I've got to have a place to store that. Member variable. That member variable, and the Project 1 STLNU talks about this a little bit, we want to use a 3D vector here. And the order matters, meaning order of subscripts. You want to have number of rooms first, followed by rows and columns. And this makes a difference in terms of memory, it makes a difference in terms of speed, and I don't want to go into a huge amount of details there, but let's just do a quick example. Let's say I had a two-dimensional vector, okay? I've got a two-dimensional vector with 1 row and 1,000 columns. Now, I really don't have a two-dimensional vector. I have a vector containing a vector. So my outer vector, there is one outer vector, and because there's one row, there's one inner vector. And remember, that inner vector has a couple of member variables. It's got a variable for what's my size, a variable for what's my capacity, and a pointer off onto the heap for where is my memory. So if I have a one row with 1,000 columns, I have one outside vector and one inside vector. I have one size, one capacity, and one pointer to a block of memory of size 1,000. Now let's reverse that. What if I have a 2D vector that has 1,000 rows and one column? I have one outer vector. The outer vector contains 1,000 inner vectors. Each inner vector has its own size of 1, capacity of 1, pointer to a block of one piece of memory. So I've got that inner overhead. So if you do like the rows first or the columns first, I could tell you, hey, I've got 2 rooms, 5,000 rows and columns. If you put that 5,000 size number of rows as the first subscript and the number of rooms last, you'll waste a lot of memory. And you'll also waste time. You'll waste time with something called locality of reference. And that we're going to get to in a couple lectures. I don't remember which one, but we will cover that. Okay, so I've got my command line option variables. I've got my 3D vector, a vector containing vectors containing something. We'll get to the something in a bit. And a deck. My deck is my search container. The deck really doesn't have to be a member variable. It could be local to the search function. It could be a member function. It's not a big deal either way. And you might need some other variables like, hey, when I read that map in, I'd like to remember how many rooms there were and what's the size, how many rows and columns are there. So you might have a couple other variables there. Might have a variable for, is there a solution or not? Let's make a Boolean for that. So we can have a couple other variables. You might discover more as you need them. Now, next thing that's important is that 3D vector, the input, that data structure, we want it to be the same regardless of the input type. So I don't care if you're reading a map mode file or a list mode file, they're going to go to the same place. They're going into that 3D vector. So from now on, when I talk about the map, I mean the 3D vector in memory. So whether it was map mode or list mode, I'm going to call it the map once it's in memory. And that's good. We want to have, no matter what the input is, the data is stored internally the same way. That way my search function, my output function, doesn't depend on the input file type. It just depends on what's in memory. So now, what goes in that 3D vector and what goes in the search container, the deck? Now, we're going to make those data structures. Let's just say structs, okay? So I'm going to have a 3D vector of structures. I'm going to have a deck of structures. They need to be different types. If you try to make one structure and put that one structure in both the 3D vector and the deck, it's going to be too generic. It's going to be too big. It's going to be trying to do 2 jobs at once. And remember what I said, that 3D vector could be of size 10 rooms by 5,000 by 5,000. Well, 5,000 times 5,000 is 25 million. times 10 rooms is 250 million. So if you make that struct too big inside the 3D vector, you could waste a lot of memory. So we've got to have two different structures, one that goes in the 3D vector, one that goes in the deck. Don't start out saying, hey, I'll just have a 3D vector of char and I'll add to it later. If you do that, you'll have to recode. So you could say, okay, the map, the what I call a tile in the project spec, the tile is going to have inside of it the character that I read in. And maybe it'll have other stuff later as I discover how to do the back tracing and discovered and stuff like that. But if you try to make a vector of char, a 3D vector of char, and then add to it, there's nowhere to add to. You'd have to go back everywhere that used to say, like, you know, the map sub-row, or sub-room, sub-row, sub-column, which meant a character, and you'd have to change that to the map sub-room, sub-row, sub-column dot the character I read in. So you don't want to have to change it halfway through. A little bit of planning will help us there. So we're going to have a structure for a tile. At first, it'll have the character you read in. And then the deck is going to be a different type of struct. We'll talk about that in a little bit. Don't start using pairs for these things. I've seen people do this with a different project one. They started out with a pair, and then they discovered they needed another piece of data, so one element of the pair became a pair. And then they discovered they needed another piece of data, so the other part of the pair became a pair. And I'm trying to read these people's code, and I'm looking at like dot first, dot first, dot first, dot second, dot second, dot second, dot second, dot first. And it's completely illegible. A pair is not any faster or more memory efficient than a structure. It's more restrictive. So I'd much rather see a struct with a couple of variables named things that make sense than dot first and dot second, which make no sense to anyone but you. Think of it as sort of a simplistic approach to reading code. I don't want to read code that's more complicated. I don't want to read code that isn't at least a little bit self-explanatory. One warning about this project: you don't want to use pointers. You don't want to use pointers. You don't want to use pointers. The only place we're even going to look at a pointer is when we process the command line, and if the output option is there, we've got to look at optarg. And if you look at our project 0, it shows you what to do with that. It says, hey, make a string variable and set the string variable equal to optarg, and that's the only time we look at any pointers at all in this project, is I take what the optarg char pointer points to, and I copy it into a string object, and then I never deal with pointers after that. If you start trying to use pointers in this project, you will find that you're going to go way over memory, and it's going to become more complicated than it needs to be. Okay, what else do we need to talk about? We need to talk about discovery. Okay, so remember we said we've got this search container, which is going to be a deck. Project 1 STLNU will tell you why it's going to be a deck, and I'll talk about that again probably a little bit later. There's this idea in the routing schemes section of the project spec, page 4, that talks about putting something in the search container and never discovering the same tile twice. Now think about what would happen if we didn't have a way to prevent ourselves from discovering a location twice. I could end up doing something like this. I've got like a bunch of number signs, which are solid walls. I'm not allowed to walk through them. And then that I call a number sign. Its proper name is octothorpe. Nobody calls it the octothorpe. You call it a hashtag, I call it a number sign, because that's what I learned it as before hashtags even existed. We still had this character, but we used it for different things. So number sign. So let's say I had something like this. I had an S here, and I had, let's say that it was unsolvable. Like the Countess is over here, and there's a bunch of dots around here, and it's unsolvable. But I start here at the S, and I discover the square to the north, and then from the square to the north, I discover the square to the south, and from here I discover that one, and from here I discover that one. I could loop infinitely. So we've got to make sure we never discover anything more than once. So discovery means I put it into the deck. Anytime you put it into the deck, you have discovered it. And you have to remember, I'm going to undo a bunch of my circles here. When the start goes into the search container, into the deck, it has to be remembered that it is discovered. And then later on, I'm going to go, can I go north from here? Well, let's see, I'm not in row 0, so yes, I can go north. Is north of me something that's valid for Marco to step on? Yeah, that's not a solid wall. It's not an enemy. And has Marco ever discovered it before? No. So Marco is allowed to add this one to the deck. Now, when I have to say, have I discovered this other location before? I can't look in the deck because the deck is my search container. Think of the deck as the places that I have discovered, but that I haven't taken out and investigated yet. We'll get to investigating in a minute. So has this been discovered yet? It's not a matter of looking in the deck. We don't want to keep like a list of everyone we've discovered because I don't want to do a linear search of that list. So think about this. In the map, every location in the map has a character that I read in. Every location in the map is either discovered or it's not discovered. So we could add to our tile structure, the thing that goes in the 3D vector, some way to remember, hey, has this location been discovered? All right? So when we start out in the routing scheme, we add the starting location to the deck, to the search container, and we mark it as discovered. We always do those together. Anytime someone goes in the search container, they get marked as discovered. Before we add someone to the search container, other than the start, because the start is the start. But after the start, when we get into looping, every time we think about adding someone to the search container, we only add them to the search container if they've never been discovered before. Okay, so then the routing scheme says you take something out of, you take the next item out of the search container, and it becomes the square that you're going to investigate, the tile you're going to investigate. Which one is next? Well, it depends on whether you're a stack or a queue. And the Project 1 STL New, our suggestion to you is always, always, always push back. And I'm trying to draw this your way. So always, always, always push at the back of the deck. If you are supposed to behave like a queue, when it's time to get the next one out of the queue, you would take from the front. If, however, you are supposed to be behaving as a stack, you would push to the back and you would take from the back. It's like a stack that grows sideways instead of up and down. So I always, always, always push to the back. If I'm supposed to be a queue, when I take the next one out of the deck, I take from the front. If I'm supposed to be a stack, I take from the back. The square that I just took out, that becomes the one that I'm going to investigate. What does investigate mean? Well, I look at where I am. I look first, I say, am I standing on a pipe? Because if I'm standing on a pipe, all I'm allowed to do is pipe stuff. Whether I take the pipe or not, I can only do pipe stuff. This is going to be really important because many of you are probably going to mess this up. If I'm standing on a pipe, I only do pipe stuff. If I'm not standing on a pipe, I look around me northeast, southwest. That is the investigating. Determining if I'm on a pipe and whether or not I can follow the pipe is investigating. Just seeing that I am not standing on a pipe and looking around northeast, southwest, that's investigating. And what investigating really means is, hey, is this other square something that can be added to the search container? If it is a valid location, right? Like if I'm in row 0, I can't go north. Or if I'm standing on a pipe that goes to room 7 and I'm in a castle with 2 rooms, I can't go there. So if where I would like to go does exist, if where I would like to go is something I'm allowed to step on, like not an enemy, not a solid wall, And if the place I would like to go is never been discovered before, I add it to the deck. That's the process of investigation. I'm standing here deciding what I can discover from where I'm standing. That's what investigate means. There's no need to record what you've investigated. So there's a need to record what you have discovered. That has to go in a data structure. But what you've investigated is what's taken out of the deck. There's no need to record who has been discovered and who has not. Now, the Project 1 STLNU, like I said, we want to use a deck here. The reason we want to use a deck and not a stack or a queue is I don't want to write the code twice. I don't want to write a 100-line function for stack mode and then copy it and change the word stack to queue, change the word top to front, and then every time I discover a bug, I've got to fix it in both of them. I don't want two copies of the same 100-line function separated by an if. Instead, what I want to be doing is I want to be saying, like, in my search, I'm going to have a loop. What is my loop condition? While my search container, let's just abbreviate that SC, while my search container is not empty, I have to get the next from the search container. Okay, and this is where I want my if. If stack mode is on, I'm going to grab from the, I'm going to take from the back, and I'm going to pop back, else, whoops, I'm going to take from the front. And I'm going to pop front. Now, as long as this is a Boolean variable and not a string, it's pretty fast. Now, you might be thinking, hey, Dr. Paoletti, I think I can beat your speed. I think if I write two separate functions and I only do that if once, I'm going to be way faster than yours, where you've got this if statement inside this loop that might be run lots of times. And you might be a little bit faster. I tested it. It's less than a 1% difference. So, to meet our speed requirements, this is a good thing to talk about. To meet our speed requirements, you don't have to be exactly as fast as us. The autograder takes our solution, runs it a bunch of times, and if you're within 50% of us on time, you pass. So if ours takes 10 seconds and yours takes 15, you get full points. If you go 16, then you start to go over us. However much you go over, your points start to go down. So you don't have to be exactly as good as us. You just have to be not terrible compared to us. So this is a place where having one function and one piece of code is a lot better than having two and trying to keep them synchronized. You might say, oh, but it's only two functions. Well, what if it was only 3 different types of containers you had to emulate? Or only 4, only 7? We don't want to have multiple copies of the same code. We want one function, put that if inside of it. Okay, now let's talk about doing an example. That would be a good thing to run through. Let's make a map here. Okay, so I'm going to make a map. I'm going to give you map mode input. Remember, the input type doesn't matter. In memory, it's going to be the same, but I think map mode is easier for us to picture, right? Okay, so I've got a map. M2, 3, and I've got a comment for room 0, and I'm going to have, let's see, 1 dot dot, here's the start, dot Countess, dot dot dot. Okay, room 1. And room 1 is going to be really simple, dot dot dot, dot dot dot, dot dot dot. Okay, so really, it's going to be laid out in memory a lot like this, right? Okay, so we're going to run through this twice, and I'm going to change colors here so I can draw on it. And let's say, okay, let's do stack mode first. Okay, now I've got to start out by marking this as discovered, and I've got to add it to the stack. But I can't just add an S to the stack. I've got to say something about where I am that goes into the deck, right? I can't just say the start location is in there. Wait, but I couldn't use the start location. What is the start location? Hey, when I read in this file, I should have remembered where the start location was. Maybe that's another member variable. Okay, so where's the start location? The start location is room 0, row 1, column 0. So that sounds like that's what should go in the stack. Okay, so what's in the stack, and this is going to change as the video goes through, so what's on the stack right now is 0, 1, 0. So that's where I am. I'm in row 0, I'm in room 0, row 1, column 0. That's what's in the deck. That's what's in the search container. Okay, so I've finished the pre-loop, put the start location into the deck, and mark it as discovered. All right, so now I've got to go through my loop. I'm running through my loop while the deck's not empty. I take the next location out. So let's make another note over here. What's my current location? So my current location is 0, 1, 0. So that's where I am right now. And I take that out of the deck. I take that out of the search container. So that's where I am right now. So now I've got to investigate where I am, 0, 1, 0. So I look and I say, can I look north of me? Okay, I'm not in row 0, so I can look north. Is it something I'm allowed to walk on? Yeah, there's a 1 there. And has it been discovered before? No, it hasn't. Okay, so let's put that in the stack. So I'm going to draw out the stack here, and I think I'm going to modify it a lot as we go through. So I'm just going to say, hey, here's my stack. Remember, this is a deck, but we're treating it like a stack. So here's my stack, and I'm going to draw on top of it. So I put on top of it, I put room 0, row 0, column 0. So I put 0, 0, 0 on the stack. That's the checking north of me. Then and also in the map, I got to mark that location as discovered, so I never discover it twice. Okay, let's look east of my current location. That would be 0, 1, 1. That does exist. It is something I'm allowed to walk on. It's a dot. It has never been discovered before, so I can add 0, 1, 1 to the top of the stack, and I'll mark the one to the east of me as it has been discovered. Okay, south of me, does it exist? Yes, it does. Is it walkable? Yes, it is. Has it ever been discovered before? No. Okay, so I can add 0, 2, 0 to the top of the stack, and I mark that one as used. And then I check to the west of me. It does not exist. I stop right there. We got to look and say, hey, that thing to the west of me doesn't exist. I don't want to go subscripting it for what character is there if it's not a valid subscript, not a valid index. Okay, so that doesn't exist. All right, I have finished investigating the current square. So I go back through my loop. I say, okay, whoever's at the top of the stack, you become my current location. So my current location is a single variable. It is not a stack or a queue or a deck or anything. It's just a single variable. So I'm going to replace the contents of my current location with 0, 2, 0, and I'm going to pop that off the top of the stack. Okay, so I'm at room 0, row 2, column 0, and I look around me. I say, can I look to the north? Yes, it exists. Is it something I could walk on? Yeah. Has it been discovered before? Yes, it has, so I can't add it to the deck. All right, let's check east of me. Does the location exist? Yes. Is it walkable? Yeah, there's a dot there. Have I ever discovered it before? No. Okay, so I add that to the stack. So I add room 0, row 2, column 1 to the top of the stack, and I mark it as discovered. I say, okay, does south of me exist? No. Does west of me exist? No. Okay, I'm done investigating my current location. Let's go back through the loop. my current location, cross it out. My current location is now room 0. I keep saying that. I got to fix that in my head. Okay, room 0, row 2, column 1 is my current location. I pop it off the top of the stack. Now, I look around me. Does north exist? Yes. Is it walkable? Yes. Has it been discovered? Yes, so I can't do that. East of me. Does east of me exist? Yes. Is it walkable? Yes. Has it been discovered before? No. So I add the square east of me, which would be room 0, row 2, column 2, gets added to the top of the stack. Okay, look south of me. I can't look south of me. I'm the bottom row. Look west of me. Does it exist? Yes. Is it walkable? Yes. Has it been discovered before? Yes. Okay, can't go there. Alrighty, I'm done investigating the current location. So go back through the loop while the deck's not empty. Take the top of the stack and make it the current location. So the current location is now room 0, row 2, column 2. I pop it off the top of the stack. And, whoops, I forgot to mark that one as discovered when I added it to the stack. You've probably been laughing at me for a minute. Okay, I noticed it now. So when I added 022 to the stack, I also have to mark it as discovered. All right, so it comes off the stack. It becomes my square to investigate, and I start looking around. Okay, does north of me exist? Yes. Is north of me something I'm allowed to go to? Yes. Has it been discovered before? No. Okay, so let's add that. Room 0, row 1, column 2 gets added to the stack. It also gets marked as discovered. And it is the Countess. So I stop searching. As soon as you put the Countess on the stack, stop searching. Don't keep going. Because if I could give you a map. I could create a map that you would discover the Countess by looking north. You discover a dot looking east, a dot looking south, a dot looking west. And if it's stack mode, you would take the west off. And from that west, you would go discover the rest of the entire map. Maybe another million squares before you go pop off the stack. Oh, look, the Countess has been on the stack while I wasted my time searching a million other locations. So you want to check for the Countess. I've been sort of skipping that in our process here. But when you add to the stack, always check, is that the Countess that I just added? Because if it was the Countess I just added to the stack, searching is done, there's a solution. I know there's a solution. Ooh, wait a minute. Now we've got a problem. We know there's a solution, but we don't know how we got here. Okay, so we need some more data to know what this path was. Okay, sorry, I just got yelled at by my wife because I'm using my professor voice and she's trying to sleep. Okay, so we've got to be able to get back to the beginning. Now, here's the thing to remember. Every square in this map has either been discovered or it hasn't. Every location, every tile that was discovered has a unique predecessor. The ones that weren't discovered have no predecessor. The ones that were discovered have a unique predecessor. But who are their predecessors? Well, wait a minute. The start is a little odd. The start is discovered but doesn't really have a predecessor. It's the start. But everybody else that was discovered has a predecessor. Let's think about this. When I started out, way back at the beginning, I started at room 0, row 1, column 0, and I said, hey, let's look north. Well, that one, think of it, how did I get there? I got to this one by moving north. The one to the east of me, how did I get there? I got there by moving east. The one to the south of me, how did I get there? I got there by moving south. The one to the west of me doesn't exist. So all of these locations that were discovered, other than the start, have a unique predecessor. Okay, so along the bottom row, how did I get here? I got here by moving east. Now, I'm drawing arrows on the slide, on the tablet here, but really, it's hard to put an arrow in a variable. What if I just put in there a letter? I'm just trying to get rid of some of those. Okay, so what if I put a letter in here like N for north, E for east, lowercase s for south, and this is going to be like another character inside of your tile. I mean, this one I got here by moving east, I got here by moving east, I got to the Countess by moving north. So now, when it's time to print some output, you have to know what's the path. When you have to start out with printing the path, you can't start at the start. The start could have gone 3 different directions or 4 different directions. You've got to start at the Countess. The Countess came from somewhere, that came from somewhere, that came from somewhere, etc., that came from the start. So that's what we mean by backtracing. We work our way backwards from the Countess to the start, and that provides us a list of directions which we could then print out in opposite order. So if I go and I look, I say, okay, from the Countess, so here's my backtrace. So my backtrace says I went north. Okay, if I went north to get to the Countess, I must have come from the south. That one says I came east to get here. The predecessor of that one says I came east to get here. The predecessor of that one says I came south to get here. And the predecessor of that one says, hey, I'm the start. So I discover it by going backwards from the Countess to the start. I discover north, east, east, south. But what I really want to do is I want to go south, east, east, north. So when I do the back trace, what I really need is like a stack, or a vector would work also. I push back to the vector, I pop back from the vector, so I can discover what I have to do for output by putting them in this backtracing container. Okay, so that's our big example with stack mode. Now you might say, what about map mode output? Well, okay, what about map mode output? See, this is why list mode output is really easy. So once you've got this backtrace, list mode output is really easy to produce. What about map mode output? Well, here's what you don't want to do. You don't want to go, hey, let's output every room, every row, every column, and for every room, every row, every column, let's go see if it's in the backtrace. No, that's a lot of searching. That's too much. Think about what if you modified what's in the map. What if I were to somehow modify what's in the map and then I could go print out the map? So think about how you could use the backtrace, modify what's in the map, and then go print out what's in the map. You can't print out all of the predecessor characters because for this one you would print out a north, but you didn't go north. That one wasn't in the solution. So you can't just print everybody's predecessor character. You'd have to do something smarter than that. You've got to use your backtrace to go modify what's in the map so that you only use the ones that are important to you. So think about that. You got to do some of this on your own, right? Okay, let's redo this example using Q mode. So what I'm going to do here is I'm going to do like a ton of erasing, and then let's see if we can redo this. Okay, so I'm going to erase all that stuff. It might have been faster to just do the, just redraw the map, but that's okay. Because we're going to use the same map over again. Okay, let's get rid of those blue marks on my map. Okay, there we go. All right, now let's do, gotta go back to a pencil. Now let's do Q mode. Okay, now my Q mode, Q is going to be hard to draw left to right here. I might have to redraw it. And then I've got my current location. Okay, so I start out the same way. The start location goes into the deck. That's room 0. Row 1, column 0 goes into the deck, and it gets marked as discovered. All right, now I start the same way. I say, okay, while the deck is not empty, take the next one out. That becomes my current location. Current location is 0, 1, 0, and get that out of the deck, out of the queue. All right, now I look north. North is It exists. It is walkable. It is not discovered yet. So I add north of me to the queue. So I add 0, 0, 0 goes into the queue. I look east out and I mark it as discovered. I look east of me. It exists. It is walkable. It is not yet discovered. So east of me goes into the queue. So I'm kind of drawing the queue here kind of in a front to back sort of way. Okay, so I add to the back of the queue. I add room 0, row 1, column 1 goes to the back of the queue, and I mark it as discovered. South of me does exist. It is walkable. It is not yet discovered, so I add room 0, row 2, column 0 to the deck, to the back of the queue, and I mark it as discovered. And here's where things start to go differently. Now, I've discovered everything I can do because west of me doesn't exist. So I go back through the loop. Whoever's at the front of the queue becomes my current location. So my current location is 0, 0, 0. And I'm going to redraw the queue here. The queue now has in it 0, 1, 1 and 0, 2, 0. Okay, so that's what's in the queue. So I'm just going to cross out the old queue just so we don't get confused. Okay, so I am at location 0, 0, 0. I have to investigate it. I say, ooh, wait, look, I'm standing on a pipe. Does the other end of the pipe exist? Yes, this is a 2-room castle. Room 1 does exist. So the other end of the pipe exists. Is it something I can walk on? Let's look down in room 1. There's a dot there. So that is a walkable location. Has it been discovered before? No. So I add it to the back of the queue. So I add room 1, row 0, column 0 to the back of the queue, and I mark it as discovered. And that's all I do. Because I'm standing on a pipe, I can only do pipe stuff. If this was a 3 I was standing on, I would say, well, I'm standing on a pipe, I have to do pipe stuff. Does the other end of the pipe exist? No. I'm done. Okay, so we have dealt with the pipe. Regardless of whether it goes anywhere or not, whether it's walkable or not, whether it's discovered yet or not, we do pipe stuff. Okay, I'm done investigating room 0, row 0, column 0. So I go back through the outer loop. The next thing in the front of the queue becomes my current location. That's 0, 1, 1 is my current location. I have to get rid of that from the front of the queue, so let's just redraw the queue. So 0, 2, 0 is in the queue. 1, 0, 0 is in the queue. Let's cross out the old queue. So it's the same queue data structure. It's just I don't have enough room to keep growing it on the right. The tablet's too small for that. Okay. So I'm at 0, 1, 1. All right, so I have to investigate around me. So I'm at 0, 1, 1. I say, okay, does north of me exist? Yes, it does. It's a valid row. Is it a walkable location? Yes. Have I discovered it before? No. Okay, so I add room 0, row 0, column 1 gets added to the back of the queue, and I have to mark it as discovered. Excuse me just a second. I had paused my TV and it caught up. I got to mute it. I'll be right back. Spent longer than I meant to on this, but that's okay. You need the help. Okay, so I've checked north of me. That's done. All right, let's check east of me. East of me does exist. It is someplace I can go. It has never been discovered before, so I add it to the back of the queue. So that's room 0, row 1, column 2. I mark it as discovered, and I notice it is the Countess. My searching is done. I have investigated different squares. I actually discovered a tile in room 1, but it wasn't in the path. So now, oh, wait a minute. When I was doing all of this, I should have kept track of how I got here. Okay, so let's go back. How did I get to the one? I got here by going north. The one to the east of the start, I got there by going east. The one to the south of the start, I got there by going south. Okay. When I looked through the pipe and I saw something somewhere I could go, how did I get there? Well, you're going to have something that allows you to backtrace. What I need to say there is that, hey, how I got here was I came from room 0. And then the one north of the center square, I got there by going north. The Countess, I got there by going east. So now it's time to produce output. The Countess says I moved east to get here. The one before that says I moved east to get here, and that's the start. I'm done. So that's how you could get different output depending on the stack or queue mode, because you will discover things in different order. You'll investigate things in a different order. So that's what makes the output different. Okay, some things, I got a bunch of tips here at the end that I want to talk about. Okay, so when you're reading input, one thing that I noticed when I wrote mine, it was just made it a little bit easier on me. When you read the input, if you see a single slash, it's a comment. You don't have to read 2 slashes to know it's a comment. That's going to make the list mode a little bit easier. When you are doing list mode, what you want to do is read using greater than. You want to read in what you want to see. What I'm going to see lots of people try to do in projects is they try to say, hey, let's do a get line and then let's chop it into pieces. And that's not going to be easy. It's not going to be easy to chop it into pieces. So it's easier to read a character. Hey, if that's a slash, then yeah, do a get line and throw the rest of that out. Or do a cn.ignore to get rid of the rest of the line. But when we're reading list input mode, we want to read with greater than. So if it wasn't a slash, it must have been a parenthesis. So then I can use greater than to read what comes next. Is a room number. That's a type of integer, not a character, an integer. I want to use it as an integer. Then I read a character, that's the comma. Then I read a number, some type of integer, that's the row number. That row number can have 1 digit, 2 digit, 5 digits. Just read into an integer. So that's basically cin goes into a bunch of things. So if I know it's not a comment, I can then read into integer, a character, integer, a character, integer, a character, etc. So in list mode input, you only want to use getLine for comments. In map mode, you definitely want to use getLine for comments. You could use it for other things also, or you could read characters. It's up to you, not a big deal. When you do output, I already mentioned list mode is easier. For the map mode, yep, I already mentioned a bunch of the things that I put in my notes that I wanted to mention, I already mentioned. So the map mode, be willing to modify the map itself for the backtrace info. And the other thing that I want to talk about, and I'm going to put this in a Piazza post also when I announce that, hey, the video is up there, is you're going to discover one of the things you have to do in this project is you have to exchange back and forth from a char that contains a digit back and forth to some type of integer. So you're going to have to change from a character that's a digit to an integer and back again. Now, one thing you do not want to do, you might say, hey, I know how to turn a character into an integer. I just use ATOI. Do not use ATOI. Because ATOI stops turning characters into integers when it encounters a \0. And if you've got a single character, there is no \0 after it. What will ATOI do? Who knows? Depends what's in memory after it. So you don't want to use ATOI. So there's a trick here. The trick is that in the ASCII table, the characters in there, there's a chunk that's all in a row. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are all adjacent. Now, what you do not want to do is look up what the ASCII value is and use it as this magic number in a formula. It makes your code very hard to read, and it makes your instructors and your staff very upset. But what you can do is you can say something like, hey, I've got a character, let's just call it C. And C, I happen to know, I know it contains a digit. Well, if I were to take C and subtract single quote, 0, single quote, the difference between them would be an integer, right? So if the character C, if the digit happened to be 3, the character 3 minus the character 0 is equal to 3. Now, we're going to have to do a little bit of casting here, so I might do like a static cast around this thing. So I might do like static underscore cast to some type of integer. We're going to come back to that in a minute. Static cast to some type of integer from this C minus quote 0 quote. All right, that's what I'm going to store into my some type of integer variable. Now, the other thing I forgot to put on my notes, but it's good that I thought of this, is what type of integers should you be using? For this project, there's almost no reason to use int. The things that we have, room numbers, row numbers, column numbers, sizes, number of rooms, are all 0 or more. They can't be negative. Also, you'll find that if you try to use a variable that is signed and you compare it to something that's unsigned, you're going to get all kinds of compiler error warnings. Now, you could use size t's, but size t's are big. Look at, remember this, Canvas, Files, Resources, Optimization Tips. Size t's are really big. They're 8 bytes each, and they have a range of 0 to 18 quintillion. I promise you, we will not give you a map with 18 quintillion rows in it. So we can move down. We can move down to what's called an unsigned int. Unsigned int is a range of 0 to 4 billion. It's half the number of bytes. It's 4 bytes instead of 8. It's way more than we'll need, but it's a really useful type. I find unsigned int to be a really useful type. However, it's not guaranteed to be smaller than a size t. What's a really useful type to use here is uint 32 underscore t. Unsigned integer 32 bits, 4 bytes, underscore t means the type. So uint32t is a great type to use for this project. So you can use it for the number of rooms, the size of a room number, a row number, a column number, a loop variable. Works great. So sticking to those unsigned integer types is really useful. Okay, so we've got how to turn a character into a number. How do we turn a number into a character? Okay, so opposite way. So if I were to take single quote 0 single quote and add some type of integer to it, that should produce a character. But I'm going to have to static cast it. So I have to do like static underscore cast angle brackets char from single quote 0 single quote plus like room. Like room is like an unsigned int 32 containing a room number. Now this is only valid if room actually contains a value in the range 0 to 9. If it contains something like room 12, bad things will happen. But this is a simple way to change back and forth between some type of integer and a character for the digits 0 through 9. Okay, so that's everything I wanted to cover. I'm going to stop this recording and get it uploaded, get a post on Piazza for everyone. So good luck with the project. Good luck getting started. Remember, you don't have to know everything in order to start. And also, be willing to come to Profis Hours. The Profis Hours has a link for the one-on-many Google Meet. Come to the one-on-many Google Meet. Even though we might have a queue open, come to the one-on-many. I've seen lots of times where people are waiting in a queue for a couple hours, and I've got a one-on-many meet with 6 people in it. There's 80 people in the queue. There's 6 people in my one-on-many meet. I've already answered all of their questions twice, and they've run out of questions to ask. There's 80 people sitting over there who haven't joined the meet. So always join the meet first, unless you know you must have someone look at your code. Because hey, if it won't compile, I've got to look at your code. If you're just not understanding it, and there's hey, this real simple example test file that I created does work, this very slightly different one doesn't work, I'm pretty sure it's this 3 lines of code right here, you've got to show us code, yeah, definitely get in the queue. But for how does it work, what should I do, I'm getting some wrong on the auto grader, join the one-on-many. We're happy to help you.